All right, so hey everyone, thank you all for joining today's call and presentation. I'm Harish. I work at Mina Foundation and I manage the Navigators grant program. The season one of the Navigators program is coming to an end, and we had around 65 participants and at its peak, around 50 projects. Uh, Currently, we have invited 12 of the teams in the program who've done exceptional work. And these 12 teams will be competing for 225,000 MENA prize pool. These teams have done exceptional work. Today, we'll have demos from 6 teams, and tomorrow, the remaining 6 will present. The format of the presentation is 20 minutes are reserved for the teams to talk about their work, and 10 minutes are reserved for Q&A from the audience. So if you have any questions, please put them in chat and I'll read them out to the project team. So please join me in welcoming the first team, which has done incredible work on a couple of primitives, ZK regex, SHA-256. Mahmoud, over to you.
Yeah, thank you, Harish. So let me share my screen and give you guys an introduction. Do you see my slides?
Yep.
So hello, everyone. I'm Mahmoud. I got introduced to Mina and the 1JS at ZK Hack Istanbul in November 2023. And I had prior knowledge in Surcom, and I found O1JS to be really interesting compared to Surcom, because if you are familiar to it, it's really painful to code in Surcom, especially it's lacking documentation, many primitives, many support on that, etc. So my hackathon project aimed at the beginning to develop a SHA-256 hash function using the newly released bitwise gadgets in O1JS. So my project at that time received 2 prizes, one from ZK Hack for the Chewing Glass prize and one from the O1 Labs for the Crypto Primitives category. And after that, I started my journey with the Navigator program starting from December 2023. So my first project was SHA-256, and the motivation was to optimize the hash function, because if you inspire from the Surcom implementation, it's a binary hash function that is based on bits, zeros and ones. And that's quite inefficient inside a circuit that is based on finite fields. So and the motivation was to optimize that by operating on 32-bit words as single field elements. And this would really optimize the hash function. So the contribution started as like, it was implemented before the release of the SHA-256 gadget by the O1JS team. And the early development was based on Surcom-inspired implementation, as I said. So I added a forked benchmarking package to that to showcase some non-provable benchmarks. And it showed that even like it's non-provable, but even with that, the O1JS using custom gadgets implementation is 50 to 70 times more efficient than the Surcom implementation, which was crazy to see. So after that, I took also the initiative to add a SHA-256 hasher class, because as you know, if you're familiar with using SHA-256, you have to update and stream pre-image data, and that might be helpful in different implementations in the future. So a future prospect of this, I'm also, at the current time in May, I'm working also on a partial SHA-256, which helps reduce a lot of constraints by hashing the relevant part of a large size pre-image. And like briefly saying that, imagine if you have really long pre-image and it's like the pre-image is unknown. So if you just prove knowledge of chunk of a pre-image, that should be enough. That should also save a lot of constraints, because chunks of inputs of a SHA-256 inside the circuit is like 5,000 rows, which is a lot. So imagine if you have multiples of that, so you would have like 30,000 or 40,000 constraints, which will block completely the ZK app. So that's not desirable also. So I would like to show you a bit how to play around with the repo. You can run the tests here. You can find also the links provided by the Navigator Notion page. So if you also want to edit it, you can digest any input you want, like this. ABC is a well-known pre-image. You will get a table like this, and you can also run the benchmark with choosing the Paul Miller's micro bmark package. So I'm choosing to do fast 20 iterations, enter, and it shows some benchmarks like these. And I also attach, so can please read the README. It's well documented with what's done, optimization, some knowledge about SHA-256. And now let's proceed to Mina Battleships, which was my second project. So I worked on SHA-256 in 2 months for December and January, and then I did Mina Battleships game in 1 month in March. So the motivation was that it was inspired by ZK CLI examples. I think most of us got introduced, like started playing around with O1JS by these examples. But what I noticed is that the examples are missing some documentation there. And they used like some serialization and many other techniques. But at that time, I didn't really know that you should do some workarounds to save the state storage. So I took that initiative to document and showcase innovative state store solutions, and of course, many other contributions to like for onboarding developers. So I built it like a role model to use different O1JS APIs, including Merkle trees, hash and salt, event handling, binary conversions. I also did some innovative technique combining different Merkle trees for the hit results, the targets, and other data. I did also some workarounds for serialization to save data storage on chain. And also, I will showcase this in a bit. It's really a good example if you want to develop a ZK app, how like to learn about the flow of development, unit testing, integration testing, and also other different security considerations. So briefly saying, Battleships is one of the most popular projects to learn ZK. I know many of you maybe are familiar with Battle Zips on Ethereum. And also that project, for example, is the first project that got me to learn ZK. So I was really like motivated to see that on Mina. So let me show you some how to play around with the repo. Yes. So the game is well documented. You have gate definition, screenshot of how the CLI visualization works, how to onboard the ships on a board, how to encode those, and motivation, ZK architecture motivation, and also solution and board, because boards are like 5 boards with like arrays. It should be only one field on state. We are using serialization in here. It's well explained with the APIs and also the code. We are doing player IDs, some security considerations with the graphs also to show how to use hash and solve. Please read the README. It's really, really good, and I hope it helps you. I have some, I can show you the code. Yes, so here you can see the code is well documented. It's using the maximum, which is 8 fields, sending also events, the code here. So we have with capital B integration tests, it's showing here that every consideration is done to do the integration tests, including call restriction to address, call frequency of methods, method sequence. Some methods should be called before some other methods, input validity, checking ranges, sizes, integrity of hashes, salt spores, etc., correctness of on-chain state updates, and compliant of off-chain. So if you want to build a secure like a secure application while also maintaining storage state on-chain, then please follow these instructions. You can see that we have utility for provable functions, unit tests for these provable functions, and I wrapped everything inside the class to facilitate integrating front end by using these components. It's using everything here like initialize host game join game, which is like a client side of what the smart contract is offering. And for that, I did, for example, here, let's check the command. Yes, so if I do npm run simulate, then it would show a game simulation with everything used. So it's now here like initializing a game with the CLI. I also have the stats here, turn count, address, and it's here alternating. See, it's like short 12, 13, turn 28, 29, etc. And then once the game is finished, I have the record in here, target 1, 2, 3, which player is the host or like the joiner. And I have hit in green as hit, M as red as missing, and P because you have to wait for the alternation of turn, which is pending. And in this case, we have, so from the stats, 34 turns, which is the shortest one, score 4 to 17, that means player 2 has lost, and this is why winner is player 1, not player 2. So it's really fun to try out. I recommend you do that also. Later on, in February, March, yes, in April and March and April, I worked on ZK Regis for 2 months, so I have a typo here. Sorry for that. Yes. So ZK Regex is the most innovative project so far I've done on Mina. We're using O1JS. It's developed as a building block and innovation. It was mainly inspired by ZK email, and it opens the world for text processing on Mina using the ZK technology also. So like to give you some background and statistics on this, regex compiler was only released by the original team in Circom and Halo. And now it's also available on Mina and O1JS. And this is a first. No other DSL, no other blockchain has this, except of like Ethereum for like maybe Circom and Halo, and also now with O1JS, which is quite the news now. So also, if you check the original compiler, it's really, really difficult to use because it's Rust-based, like transpiled to TypeScript using ROS and Bingen, and they are like trying to reveal some sub-patterns of regex using some JSON files. So you have to write your own JSON files. You have to define which public, which private sub-pattern you want to show. And that was even like to this point, I couldn't use that comfortably. So, but I will showcase this later to you with the ZK regex compiler and O1JS is only one command in terminal. So why ZK regex then, and what can do for us? So ZK regex can process a string as you want. So if you give it a pattern, then you will proceed to pattern matching for that. And that will also help us to validate certain patterns of regex, and also revealing substrings of regex. And I will showcase this to you later. And this also helps, like, why do we need this, like, on a higher level overview? We need that because if you verify, for example, in emails, if you verify RSA signature and you have also the email body. So now we are having the email body. We have some information inside the email body, for example, a name of my Twitter handle, like my Twitter handle or some other information. So I can really scrape that from the email. And ZK inside the blockchain, which is really revolutionary concept to do. So I would like to show you in a bit. I think I have 3 minutes. So what I noticed is So regex is based on what's called the theory of computation, and specifically DFA, deterministic finite automata. And to do that, you can really open the world for UTF-8 byte control flow with conditions. So instead of working on UTF-8 bytes, we can also work on finite fields, full-size finite fields. And imagine what you can do with that. Because you have like repetitive operations, you have OR, and you have negate. Like it's impressive, and that should I would hope to see this also in the future. And this will pave the way for complicated multiplexers, methods on arrays of fields. So we can see something like find, search, any, etc. And for now, I will show you is like it compiles a string that you have to copy and paste, but it's also could be, especially because it's in TypeScript, that we output circuits at runtime. So let me show you the README. So one simple command is to do npm run zkregex, and I would like what to do here is az plus, which is I want any alphabetic lowercase pattern, and I'm doing nothing here, and that means it will be a boolean to validate pattern matching, and then it will also like there will be no revealing of subpatterns in here. So if I do enter, I will get something like this. Row regex expanded with mean DFA JSON graph, and this is the circuit. How you can use the circuit, for example, I come here, I do examples, and I do, for example, in here, function simple reg, and then I do Control V, then you can use the circuit as easy as this. Also, I will show you the README. There will be like a good description here how to use it. You have to also import some the field types pool and uint8 from o1.js. This is a sneak peek on command from the compiler, and we have compiler options. They are well described, but I will show you here. This is the DFA, the theory behind regex. You can also use it in a link like this. So here is the final graph we have. So you input your regex pattern. If you want to reveal some substrings, then you go do some transitions in here or regex patterns. With transitions is more manual, but please focus on security using regex subpatterns. So for example, this command npm run zkregex, good or bad, but I only want to show, for example, good. And mainly this revealing things shines with patterns like repetitive patterns like az plus, which also, because you don't know beforehand what the text will be. For example, if I try to reveal certain patterns, like let me do regex like this, name dot, so it's gonna be then I want A to Z capital. That means only one letter, which is capital, and then only like lowercase letters that are one or more. That's why we use the plus operator. And then what we use is I only want to show the A, AZ. Sometimes I have to pay attention. And yeah. And I will not do the count, I will do Boolean validation. Yes, so you see here, instead of, as recently seen, out, which is only a Boolean, we have out, which is a Boolean, along with the revealed substring. So here you can see in the comments from the compiler, revealed transition A to Z, and that means that, yes, I will only see the name. I'm also like here, ignoring the first letter. So I think it's time. Thank you very much for your attention, and I will leave the word to you.
Thanks a lot, Mahmoud. Currently, there are no questions in the chat, but I will ask one or two, depending how far we get. But if the audience has something, please put them down. Um, My question was, you spoke a little bit about changes to like Merkle tree structures and optimizations, which you had done as part of your Mina Battleships game. Could
Yes.
you please talk a little bit more about what those were?
Yes. So I can showcase this in code also. So there are like two different APIs in O1JS to use, which is Merkle trees or Merkle maps. And Merkle trees are based on indexes from 0 to n, like a certain number. I'm using only like 2 to the power 8, which is 256 in this case. And you can also like use Merkle maps that they map some keys to values, like field to field in this context. So what I did here, I also like explained this quite well in the README, is that I'm having a hit Merkle tree with target Merkle tree. So I'm having each target, and I want to map it with hit, which is a Boolean. It will say like it's true or false. So what I did is, because there's like a lag of one turn behind, because you are waiting for the adversary to prove, mapping with using Merkle map won't make much sense, and it won't be secure. And this is, for example, one advanced use case I use is like to assert when you initialize a game to have an empty root of each trees. That's why in here we have init game. You are setting empty roots to both target and hit root. So what I did is like quite innovative. I'm taking the index of each target and hit Merkle witness, and I'm asserting the relation, the connection between target tree and hit tree. So I'm using also the index of each tree. And when I also get a leaf from the user, I'm also asserting that connection. And I also update the hit Merkle tree until I make sure that I'm getting the correct target as well. So it's a mapping from index to fields. And that way uh, I map two Merkle trees together. One optimization to do with this is that imagine if you have 8 trees and I want 1 to 7 mappings. So I can use the first tree with the index I want and map it to 7 values by doing the same technique to other 7 Merkle trees. I hope this answered you, Harish.
Yes, yes, thank you very much. There's another question in the chat. Satyam has asked, have you thought about publishing regex code as a node module?
Yeah, so yes, that's a good question. So it's not a package now. I published all of the things I did so far as packages, but not ZK regex, because I did that in only 2 months, and I didn't have the time to wrap it inside an executable, like a CLI executable, which is like I would need to use it to use Commander or Oak Cliff for this. I didn't have the time, unfortunately. And also, like, the discussion is ongoing to whether keep it compiling at runtime or just copy pasting strings, because like for some people, just these strings are like maybe a bit ugly.
Gotcha. Thank you so much, Mahmoud. I don't think we have any more questions. So thank you for coming on and presenting.
Thank you all for your attention.
So I believe we can move to the second presentation of the day. The second presentation is Zknoid, and Andre and team, would you like to come online? Andre, you're on mute, sorry, so we cannot hear you.
And now, can you hear me?
Yes, yes, we can.
Yeah, that's nice. Very glad to present our project today. So let's start. Can you see my screen?
Yes, we can see it.
Today, I'm Andrei. I'm a co-founder of the Knoid project, and we, with my friend Alex, who also a co-founder, would present you our project, the Knoid. The Keynote is a gaming platform that was built on Yatar Global Hackathon in Istanbul. We was wondering how to connect gaming and the key proof, because we think that the key proof can greatly improve user experience in such fields like gaming, but we wanted to implement an approach where the key proofs would be very useful. We came to the provable competition concept. This means while playing, you create a ZK proof of the entire game process. And this proof verifies that you really completed the game level and you are really not cheated and all the game math is correct. With this idea, we implemented our platform. All the games are provable and all the leaderboards contain the proof that game was taken fairly. Our mission was to implement provable games with provable game process. For our mission, we used the case circuit that allows us to prove the game math. We used recursive proofs for games where proof is accumulated while you're playing, like Arkanoid. Every tick, a new proof is generated using the previous one, and while you're playing, the final proof can prove the entire math. And we use protokit network for fast transaction because mainnet block production is not so fast, and we use upchain solution to bring good user experience and allow to make multiplayer lobbies and background sessions. Background session allows player not to sign every transaction in the game, but let them be executed on background while you're playing. We are part of Mina ecosystem. We are in close connection with protokit team. We help them with configuration, deployment, testing their new features. We was the first project who deployed the sequencer live. We was the first project who implemented such things like initial data pushing to the network, like default competitions. We're the first project who tried the persistence feature that allowed not to reset all the network states when is restarted, but to keep all the state. So it's quite an experimental feature for now, but we were first to set it up. We published a protokit tips and tricks article that was quite popular. It was reposted by protokit channel. It was used in mini lecture materials. Also, we're in talks with our wallet team. We are integrating our L1 token. The standard is not so, there are no token standards, so we're developing a solution to make a Mina fungible token work with our wallet. Also, we are collaborating in mobile ZK app support, so we're delivering our game store on mobile Aura wallet. We are in talks with the Keon network. It's an MPC network that provides oracles. We use it to feed results to L1 network, like competitions results, game outcomes, and we are communicating about using their price feeds for USD prices in game. And we're integrating Pallet Wallet to our platform. It's a new platform on Mina ecosystem. It requires a special integration. And we're in talks with our marketing supporters, AtlasPad, StakePad. It's the developer of Minascan, the KYOC, and Zico network. From developer side, our platform is built of modules that can be reused in different games. We have quite a modular design, so there are a lot of parts that can be used by anyone who wants to build his own game. So you can just plug in modules and easily launch your own game connected to the store ecosystem. Our first game was developed on the store is Arkanoid game. In this game, your goal is to break all the bricks on the field, controlling the cart and beating the bouncing ball. While you're playing, every tick is accumulated as ZK proof, and the final recursive ZK proof is used in scoreboard, and all the rewards are distributed fairly based on the provably fair gaming process. Here is Renzu game. We wanted to create a multiplayer game on Mini Network to bring more interactivity, to allow players to play at the same time. It's a tic-tac-toe-like game where you need to collect a line of pieces, five in a row, in a column or diagonally. So first player who created a line of his pieces, five in a row, wins. It was our first PvP game concept, and we developed matchmaking and lobby manager for this game. Then we wanted to implement our first live game, Symbolic game. It's a game where one player hides a ball behind one of three symbols, and another player guesses where the ball is hidden. If guess is correct, he got the reward. If guess is incorrect, he got no reward. So in this game, we use commit reveal scheme. It's when you first commit to the network the hash, the salted hash of your guess, and then you reveal the initial guess with salt, allowing to publish the initial guess without revealing it to the network initially. So we implemented commit reveal scheme model for our store for this game. Uh, Now, my friend Alex will show you how our development goes within the Navigator program.
Hi guys, our journey started on November at Global Istanbul. We participated in hackathon and created prototype for Arkanoid game. We won second place on Mina and also received our Navigators badge. So as Navigators, we started on December. And first thing that we should manage was that our front end and back end wasn't fully connected. So a user should play a game, collect his game inputs, create proof by himself, and send it to blockchain. Not the best UI, as you may suggest. So on December, we fully connected front end to back end and improved UI. So a user now will play a game, create a proof within a browser, and send it to the protokit also within the browser. In January, we improved Arkanoid even more. We had a problem that Arkanoid game was fixed game length because we used simple proofs. So the game length was constant for each run. For fixing this, we used recursive proof. So now game input split into smaller tasks. Each task creates smaller proof, and then it's reduced to one big game proof. Also, as a game platform, we wanted to cover as many game types as we can. So the next step was to develop some multiplayer game, and we decided to develop Renzu. Also, we had a big problem with design. We didn't have this at all. So Shiroi, our designer, joined the team and helped us to fix this issue. In February, we had already Renzu as a multiplayer game, but the problem was that you can play it only on your PC within different browsers, not only on your PC. The problem was that protokit could be deployed only locally, and you can use it only locally. It was not fun at all, so we found a solution and managed to deploy protokit sequencer to public, so you can play wherever you want and connect to our sequencer. Also, we improved design quite well. We redesigned main page, game page, and other. And we rebuilt our architecture to be more modular, so the new games can be added quite easily, and other developers can reuse it. Also, in this month, another part of our team, Nikita, joined us to help us with design. In March, we decided to expand our game types coverage even more. So we developed a poker game and SDK and simple design for it. So we can implement card games using homomorphic encryption to make a provable shuffle. So technically, we can build any card game now. And we also created a Timberlake game that based on commit reveal scheme. So again, technically, we can build any commit reveal scheme, such as battleships or Thimblerig. In April, we ask ourselves a question: if we move in the right way, is UX is good? So we decided to conduct a testnet on May and started to preparing for it. So we put some tasks aside, like finalizing poker and other games, and we decided to finalize task for testnet. We conduct ourselves tests and find bug ourselves, fix them. Also, we improve the UX greatly. For example, we add lobby options, so you can find a game not only with matchmaking system, but you can create your own lobby and send a link to a friend or just wait for someone to join it. Also, we added mobile support with our wallet, so people can use our site with mobile and play games also with mobile. And finally, in March, we conducted testnet. It finished yesterday. We received a lot of bugs and fixed a lot of bugs, of course. But not only that, during testnet, we managed to implement brand new protokit features such as persistent store and new O1JS for protokit. And also, not only we managed to fix our own bugs, but also we helped protokit team to debug their own bugs. And now Andrew will tell you about some numbers from testnet.
Thanks so much, Alex. So we're really proud of the testnet results. We have the following project traction. We got like 100 testnet participants who solved at least one task. We have 12 participants who completed all the quest tasks, and we have almost 6,000 test Mina bridged over the platform. While developing within Mina Navigators, you got a lot of interesting moments, and here are the moments we are really proud of. We took the reward for best smart contracts and UI within Navigator program. We launched the testnet event with the great traction. We created not just a gaming platform, but a reusable ZK gaming SDK that can be used by anyone. And we have one external developer who tries to create his own game using our SDK. Also, we have a lot of researches and investigations about ProtoKit, about ZK gaming. We created a lot of educational articles that was used by many teams, mentioned many times, and used as a material for Mina lecture. We was the first project who goes live with ProtoKit, and we completely implemented checkered game using our SDK in just in 3 days in one developer. So our SDK allows anyone to build his own game so fast, and it's extremely useful for hackathons or new games building. Let's see our plans. So for June, we are going to launch an L1 lottery. So when Mina goes live, when Mina goes mainnet, a L1 game will be ready to play, and we're going to start unramping users to Mina as soon as possible. We are going to finish poker game. We are working with our wallet team to finish our token integration. We are working with Pellet's wallet to integrate it to our game store. In the year, we want to implement more games, organize hackathons, launch more L1 games, finish audit for protocol-based games to launch them mainnet, and build a strong community, connection with bloggers, YouTubers, VCs, acquire audience, and bring ZK gaming to everyone. So now let's see how it looks like in reality. Here is our game store page. Here you can see a lot of games. So we have 4 games ready to play now and 2 games that will be ready soon. First one is Arkanoid game. I just enter it and choose a competition I want to play. For example, the first one. And my goal here is to beat the wall and break the bricks. And or every tick, I can click debug mode here. Debug mode shows how it looks like in circuit, how it is reproduced in circuit. So every tick is synchronized with the key circuit. Let me show you a second game. It's a random game. Here I want to create a lobby. A lobby allows me to play with my friends, colleagues. I enter the lobby name, create this lobby, and when lobby is created on blockchain, it will be appeared in lobby list. So anyone can join the lobby. I'm ready to play and waiting for an opponent to join. Uh, Alex already is here. He joined my lobby. Now transaction is executed, and when transaction is executed, game is ready. So it's my turn now. I can put my piece and here and wait for Alex's turn. And I need to build a line of my pieces. When I got 5 in a row, I win. So it's like a tic-tac-toe game. So I'm playing with Alex. Let me show how it looks like. It's a pretty simple moves. In reality, it is hard to play because one player uh, tries to make other player break the line. Uh, I put my piece here. I got 5 in a row, so I'm winning in this game. So I have 0 winnings because I created a lobby that is free to play. Uh, Here is a simpler game. It's also a lucky game that use commit review scheme. I create a lobby here as well. So if you want to play for money, you can choose a participant fee. I click ready to play here and waiting for Alex to join my lobby. I could also share the lobby link so anyone could play. Uh, Waiting for Alex to be ready to play. So now I need to hide the ball. I want to hide it, for example, here, signing transaction. Now I committed to network the salted hash of my choice, so no one can know what is my decision. But when I reveal it, anyone can know what it was initially. So now I reveal position, so anyone will know where I hit the ball initially. Once revealed, revealed, I see the result. So I won because Alex incorrectly guessed where I hit the ball. So I won in the game. Uh, we so all the games leverages models that can be integrated by anyone. Our platform is quite extensible. Here are our docs. Uh, they contain a lot of information, but I want to show you the SDK docs. We have already models that can be integrated by anyone. For example, to create a game, you need first to create a config for your game with ID, name, description. You need to define runtime models that will be used within the game. So if you're a developer, you can easily reuse all the logic for our game. Also, we have a bridge functionality to play for money and to transfer money from L1 from Mina to the ProtoKit chain. I click bridge button here, click confirm button, and funds are bridged. So I got my Mina burned and transferred to the balance. So here I have a balance and I can play for this balance in the games. Also, we have a lot of educational materials. If anyone interested in how our platform built, what is ZK Gaming, you could check out our blog. We have a lot of interesting articles, for example, with progress of our platform, how it we deployed through the time. So that's our educational materials. You could check them in the blog. I think it's the main part I want to introduce today. So do you have any questions?
So I'm looking at the chat. Well, Satyam has a shout out. He says, kudos to the entire Zknoid team for building the awesome SDK. I can put a question forward. Can you talk a little bit about what areas are you researching currently related to provable games, and what bottlenecks are you trying to solve?
Yeah, I can answer this. For now, for this month, we're looking on L1 contract because previously we were building fully on protokit. So now we want to do something on L1. And also the bottleneck that we are trying to solve is user experience, because, for example, with L1 contract, when you sign a transaction and send, you need to wait 5 minutes or so long. So and also with proof, if you need to prove every return, you also spend a lot of time for proving. So we want to make it UX better and sign and prove less part, but be as secure as with proving everything.
Yeah, what a bottleneck, let me explain. We really want to make audits of our platform. We want to wait for protokit audits. It makes it hard to go to mainnet because of protokit is not audited. So for this reason, we want to implement L1 game that will be ready to play. Also, we are very eager with card games because we implemented the entire card games SDK, and we want to build more games with cards.
Cool. Thank you. Vincenti has a question. Do these games require any kind of a gambling license, or how does that work?
Our main focus is to build like board games,
Mm-hmm.
not like games. Like games also presented, but it was not the main focus of the platform. Regarding gambling lessons, we will think about this question when we go mainnet, and maybe we can like disable some games if it
Mm-hmm.
comes under if it requires gambling license, but our main focus is board games, card games, and things like this that is not gambling.
Thank you for answering that. Another question is, can you show the L1 to L2 bridge, and is it working?
It's let me show how it works. I can like enter any amount of tokens I want to bridge. It's we are waiting for protokit official solution,
Mm-hmm.
but we created our own bridge for now. This is quite secure but not decentralized. So
Mm-hmm.
we need to wait for protokit solution to make it really secure.
Gotcha. And I assume it's like a two-way bridge. You could bridge both to the app chain and back to the main network. Um,
Yeah.
Awesome. Thank you. I don't think there are any more questions in the chat or from me. So thank you for coming on and giving us a demonstration.
Thank you very much. I was really it was really really happy to present the project today.
Yeah, thank you guys. So the third project for the day is ID Mask and Ridas. If you are online, could you please share your screen?
Yep. Hello, everyone.
Hey.
Good to see you. Right. You guys can see my screen, right? Nice. Okay.
Yes, we can.
So, hey, Maren. So yeah, I'm going to be presenting ID Mask. And so I, together with Marin, we've been developing this product. So Marin is the CEO of the company that we established, and she's managing all the partnerships, and she's pitching the project to programs and so forth. And I'm the sole developer, super team. Right. So ID Mask. ID Mask is about allowing the users to prove statements about themselves to third parties without revealing any personal data. So that's the basic idea. And let me just delve into some charts where we can distill this whole app into some simpler terms. So essentially, what the app is all about is about fetching your proper personal data into the client side, then passing it over to the ZK programs that will do something in the circuit and output a proof of something about that person. And then what we want to do is we want to save these proofs somewhere so that it's convenient for the user to save them and then later on to use them. And for example, for let's say a club bouncer to verify my age easily without much hassle. So the project has been funded during ZK Ignite 2, and since then we've been adding new features and working on it and improving the product. So the blue parts are something that we've developed long ago during cohort 2, and then a number of features that we added on top that modified either our UI or the circuits themselves, and or for example, the way we store the proofs that the users create. So yeah, so to put it shortly, the app is pretty simple. Yeah, we fetch the personal data, we pass it on to ZK circuits, and we somehow save the proofs created. Let me move on to the new features that we've pulled off during the last months during the Navigators program. So we've created a new proof. So proof of nationality. We've developed the way to store and consume proofs using Google Wallet via QR codes. Very neat feature, very useful. Then we've developed the proof of ownership verification mechanism. So I understand this is hard to digest and like what does it even mean, but I'll show you very shortly. Then we added a cache to the client side so that the ZK programs run faster once the users are creating the proofs, and then generally updated the UI so it's more user-friendly, because previously after the cohort 2, it was really messy and more like developer-oriented rather than user-oriented. So, okay, so before delving deeper into the details, I want to go back and just show how the app works so you all get the feeling, like, what is it? What does it do? So, okay, here's the app. What we do is we select the proof that we want to create about ourselves. So currently we have 4 proofs. It's proof of age, proof of non-sanctions. So that is proving that I'm not sanctioned by the OFAC. Then proof of unique human, and then proof of nationality. So let me just go on and create a proof. So creating a proof, in total, we have 3 steps. First is it's the question of how do I fetch my personal data onto the client side, right? So I can either use mock ID, which I'm not going to do. You all guys can do that, or I can select a proper smart ID authentication that is fetching like proper data from people that are living in the Baltic states. So, okay, so what I do is I input my personal identification number. I request my data, and then I get a notification on my phone. I have to match these numbers. And once I input my secret PIN, I've just fetched my personal data onto the front end. And now I can create a proof of nationality. So basically, what this is going to do is take the country that issued my passport and pass it over to a Ziki program that will verify inside the circuit the Ziki Oracle response, various other things will parse the country to a 2-letter code, and then we'll create the proof and output it. Once it's created, as we see, I can then save it as a JSON, put it on chain, which I'm not going to delve deeply into it, or I just save it to my Google Wallet. That's what I'm going to do. And once I do that, I add it to it. And so basically, right now, I'm carrying my proof around with me on my phone, and I can easily present it. So let's say a bouncer in front of a club, or maybe a supermarket at a self-checkout. So let's go into the shoes of, let's say, a bouncer. And I'll just show how this whole process would look like. So someone that consumes the proof would go into the ID Mask website, would go into the Verify tab, and would say, hey, I want to consume someone's proofs via QR code. And then he's going to, I am, as someone who presented the proof, will give him the proof. And this is the information that he's presented with. This is a proof that I am a national of Lithuania. So just 2-letter code. The proof was created today, and the proof validity is true. So what we just did, we verified the proof on the front end. So real quick, I'm going to turn on the additional feature that we've developed, and that is about tying the proof to your Mina wallet. So whenever I create the proof right now, I'm being asked to sign my personal data, and that is personal data. That's my personal data converted to field elements. And then once I do it, I am not only creating the proof that we just saw, I'm also tying that proof to Mina public address. Why do we want to do that? We want to limit what we call proof transferability. So if I created a proof, I don't want to be able to easily give it to someone else, right? I want it to be only used by me, the person who created it. That's why we want to tie it to a public address and then limit the usability of it. So let me repeat this whole process, and I'll now show you how does it look when we try to consume proof that is being tied to an address. So right, you see, so we have an additional field right now. So it means that the proof was created by someone that owns this address. And what we can do is we can essentially create a challenge for that user, so that we ask, hey, do you still own that same address that you've created or tied the proof to? So we can just click this button, and essentially what happens is we create a QR code that the user, would now scan with my phone. And I'm not going to do that. I'm just going to click the link, and you'll see what happens. I am being asked to sign an arbitrary piece of data, hence proving that I still own the same account with the same public key. So if I sign the data, then on the front end, the proof consumer says, okay, so that person still owns the same account, and we have this little check tick over here saying that, right, this is still as if the same person. Cool. Okay. Now, let's just go a bit into some of the details. So, real quick, how does the proof of nationality ZK program look like? It's pretty simple. So essentially what we defined two different data structures, like what is a personal data and what's the public output of this proof. So the personal data is basically my name, my surname, my country, personal identification number, and current date, all expressed in either circuit, strings, or fields. The public output is the nationality expressed in a single field element. The current date is, again, a single field element, and the creator's public key is the public key. Right, so, okay. The ZK program doesn't have any public inputs, only private inputs. So the set of private inputs is my personal data, my ZK Oracle signature, that is personal data that is signed by the ZK Oracle, the creator account signature, and creator account public key. And then inside the method, what happens is we first verify the ZK Oracle response, then we verify the creator signature response, just the creator signature, and then we parse the nationality. Well, how we do that is we convert nationality into a single field element, or if you wish, just a four-digit number. What we use is we use the alpha-2 country encoding, very simple. So just two letters that map to any country, right? And we encode every letter as a decimal. So, for example, A is 65, I don't know, R is 82. And we use this logic to convert my country to a single field element. Right, and then the proof is outputting this data structure. Very simple. This is what we've seen before when I presented the demo. And then there's this additional logic where we can recursively consume that proof with a smart contract, and then essentially effectively putting it on chain. What we do is we define a smart contract that takes in a single element into its function verify proof, and that element is the proof of the ZK program defined above. And inside the method, we just verify that it's a valid proof, and then we emit an event, which then later on can be consumed by any other app. Okay, let's move over to some of the Google Wallet logic. So how is this part implemented? So essentially what happens is the proof size is bigger than Google Wallet allows us, like the maximum size of the object that we can save inside the Google Wallet is smaller than the proof itself. So we had to figure out a way to overcome this. So what we did is essentially what we're doing on the client side is creating a secret key for encryption, encrypting the JSON proof, uploading it to IPFS, and then storing the following JSON on the Google Wallet. And whenever we consume the proof and read the QR code, what we're doing on the front end is fetching this IPFS hash, pulling off the proof. So just for convenience reasons, that's how the encrypted proof looks like. Then we decrypt it and then run verify methods on top of it. Also, because I can't show you my screen, I'm gonna quickly show you how these proofs look inside the Google Wallet. So I made this recording yesterday. So this is the Google Wallet app. On the top, we have some credit cards, and then here is how proof of nationality looks like. So this is how proof of unique human looks like. So essentially, these are just the QR codes that we can carry around with ourselves everywhere, and this is very convenient. So that's the end result of this functionality, basically. All right, so I think that's it for Google Wallet logic. Then the proof ownership verification part. Okay, so that's the part of the app where, let me see, let me just generate this part again so it's easy for all of us to understand. So that's this part. What happens is we want, so the basic idea is that we want to demonstrate that the user still owns a private key that belongs to the public key that is tied to the proof. So we initialize the session on the front end. The consumer of the proof initializes the session by sending a post request to our backend, and essentially it creates inside a temporary storage just session ID with a null, just key to value map, and then it creates this QR code which the user can scan, and then upon scanning of it, the following happens. I'm asked to sign this arbitrary piece of data. I sign it, and then the front end, the proof consumer can see that I still have that same key. So yeah, and then what happens is that the proof consumer only verifies and matches if the signature of the signature still match the signature on the proof. Yeah, and I see zk team also using this. For me, it was the first time I did this, but it's like very convenient, or a wallet API that lets us simply sign messages, and it doesn't require then for us to necessarily interact with the Mina blockchain. And all of this so far, what I've shown to you, we've only basically used O1.js and haven't interacted with the Mina blockchain in a sense at all. Right. Okay. And then the final thing about the cache implementation. So, right. So the cache implementation basically sped all the things up, and it made the proof creation much, much easier. So also shout out to Chris 1897, who I think first came up with this simple implementation of cache on the client side, and we're still using it. So the basic idea is super simple. You have a list of files that are associated with your zk program or a smart contract. This is the list of files, and then you simply fetch these files. You create a promise all whatever function, and you fetch all of them, and then you mount the file system together with these fetch files to your zk program or smart contract and compile it. And this is way, way faster compared to not using the cache. I really like that we implemented this. The basic idea is super simple, and it makes the user interaction much, much better. Right. Okay, I think, yeah, these are the 5 basic new building blocks of the ID mask that we built over the last couple of months. And if there are any questions, I'm happy to answer them.
Thank you very much. There is one in the chat, which is to make it work with other government IDs of other countries. How easily can we do that? And have like a question which is very close to it. Basically, I think it's the ZK Oracle which is responsible for signing the primitives. So maybe if you could talk a little bit about that, that'd be great.
Yeah. So this is something we've been constantly on the lookout for together with Martin. I mean, we're looking for some systems that we can easily use to fetch personal identification data. And we have on our radars a couple of them. So first we thought about the Ausweis app, which is basically an app that allows us to do that inside Germany. But we haven't figured this out completely yet, because the Ausweis app interface is relatively like poorly documented and hard to implement. But I don't know, maybe even Maren, you can comment on the Swiss ID integration.
Yes. Yes, thank you. I would love to. So in Europe, there are for several countries similar apps like the Smart ID app. And yeah, like Raidas mentioned, the intersections there are sometimes better documented than than other times. For example, the Swiss ID one is pretty well documented, and they even have a team that is communicating with us and is trying to be very helpful in the implementation process. So I think we will try to we can sum it up, and we are trying to get the low-hanging fruits first and then but we're constantly on the lookout for other EID apps that provide us with a similar functionality like Smart ID.
Cool, thank you. Struck mentions India's Aadhaar card would be interesting. So it's just like another UPI interface, something to look at. I don't think there are any more questions in the chat. So thank you very much, both Raidas and Maren, to come on and present your work.
Thank
Thank
you.
you.
Brilliant. So we can move to the next project of the day, and that is Doot. So Anuj, if you're online, stage is yours.
Hello, am
Hey,
I audible?
Anuj. Yes,
How are you?
great, great.
One second. Is it visible?
Yep.
Yeah. So Dooth is an Oracle project that is supposed to provide data feeds directly like compatible to Mina protocol. So we were part of ZK Ignite cohort 2, and then we continued to Navigators. So initially, like what led to Dooth initially, so there was no production level data feeds protocol available that provides us with OpenJS compatible data feeds and something that can be used in smart contracts directly. Like we didn't have any fields or signature that we could use in smart contracts. Apart from that, since Mina uses the off-chain execution model, it opens up the opportunity for any protocol to change their data, what do you say, price provider in between that can lead to loss of, what do you say, loss of wealth in the greater sense. So, and also there was no way to verify if the price was generated by the Oracle or not. So that's one of the things. And second last, like even if somebody used an Oracle for that, like if they were using just one Oracle, it could lead to faulty data on no data at all. Also, what do you say, impacting the whole economy of a protocol. And lastly, like creating your own oracles for Mina protocol, the process is kind of complex and it takes a lot of time to establish all the small details. So that was one of the blockers that I faced initially that led me to, what do you say, create Dooth. So right now the infrastructure is divided in like mainly three parts. The first is the website, the backend, and apart from that, we also have on-chain part of the protocol. So let me take you to the website first. So this is the landing page of the website. We provide supercharged Oracle for Mina protocol, and we provide data feeds for like that focuses on transparent, accurate, precise, and provable nature right out of the box, which isn't available on Mina. Like before ZK Ignite cohort 2, it wasn't available, but after cohort 2, we managed to provide some value to the community in that sense. So if you go here and let's search for the current price of Ethereum, we can see like we have the price in field format, the decimals. We also have timestamp and a signature that can be used in a smart contract. So for the backend, so the main infrastructure of Dooth is it's dependent on cron jobs that run 24/7 to generate the prices that we have. So if I take you to this, So this is the main component that generates the price for a specific token. So what it does is it recursively calls multiple data providers. It firstly like removes the data providers that generated a faulty data or provided no data at all. And after all of this is done, it removes the outliers. So this is using a MAT score. So after the what do you say, the noise is removed, we aggregate the final price here. So this is the mean price that comes out. Like this is the sum. We process it, we aggregate it, and this final field is signed. So the aggregated price is like you can verify the signature for the aggregated prices that this is part of this process. And apart from that, like for individual calls, we also had this call and sign module. So what it does, it after it gets the response from the data providers, it what do you say, signs over the URL call the price that was returned, the decimals we are considering, or the what do you say, how precise is the data. So we consider 10 decimal points for this and the timestamp when it was returned. So this is also signed. So essentially, like if I go over to this, so let's consider the latest data point that we had. We have an aggregation signature that is like same for everything, because like let's say serial number one is part of the latest historical price that was generated for Mina. So the aggregated signature is same, the aggregated price is same, but if we go over to the provider and the price, we see like we call Binance provider, the price returned was this, and this was the signature unique to the Binance data provider. And we are also continuously timestamping every process. So this timestamp was considered when Binance was called, and this timestamp is considered when the final aggregation is taken care of. So this is one of the most important, what do you say, cron job that runs 24/7 to generate the price for each asset. And apart from that, we also have historical information. This historical information is taken like every 30 minutes for each asset, and then it is pinned to IPFS. And apart from that, we also have an on-chain verification module, like we have a smart contract. If we go here, so this is the main function that is called by the Oracle continuously. So what it does is it takes the commitment that is generated by mapping the, what do you say, the name of the asset to its price. So commitment is created with the map, by the root of the map, and this is the pinned IPFS CID for that. So this is like the major part of the infrastructure that keeps on running to provide the like to keep on updating the price. So we go ahead and to like explain how the price is generated. We have a list of data providers we call regularly to get the price information. So this operation is wrapped up, and the signature contains all the, like it marks as a stamp that this was done. After that, the returned information is filtered using the outlier scheme, and finally the remaining prices are aggregated, which we saw on the historical information. Now, where exactly can Doodh be utilized? So any ZK5 application on the Mina protocol that wants a OpenJS compatible and verifiable price feed service. So these usually include prediction markets, NFT marketplaces, future options, and swaps. So let me go to the website. So this is the feeds, what do you say, user interface we have for this for Doodh. So we are currently tracking 10 top assets for now. So if we go over to Mina, this is how it looks. So this is the pricing information for the past 24 hours. We have listed the data providers we are using, and this provides what do you say, a general summary of how the price was produced. So this was the aggregation timestamp when the price was generated. This was the data, and this specific field is how many data providers like that were used to produce the final price. And this is the aggregation signature and the Oracle public key. So where can we exactly use all of this? We have a verification page for this. So so essentially what a platform can do is request data from Doot, and after it's done with that, it can also use the npm package to verify the, what do you say, the signature generated. So what it essentially does is, so let's take a signature. You have the signature, you have the data. So it takes a bit of time and it can verify if the signature was indeed generated by the Oracle keys. And this thing can be utilized to to add a step between the final pushing of data on chain and before and getting the data initially. So if I say like the data was something else, so like it will continuously fail that this data was indeed not generated by the Oracle. So this is like one of the important things that can be used to prove to verify that the price generated was indeed generated by Doot. And this is the user dashboard. So essentially, let me take you to. So this is like an interaction script where we can use Doot. So we need to get a Doot API key, and for that we have a dashboard. So anytime a user logs in, they can go over to the dashboard and it will create the API key for them. And you can get the API key from the bottom of the page. And after this, like if you see, this is the script that actually like works usually. So if I go over here, this is just an example script. The anyone that wishes to use Doot, they can create their own interaction scripts. So for now, like we have the client that is getting the price of Mina and Ethereum right now. So let's see. So this was the price that was that was returned by Doot. So if we go to the user interface, we can. So for Mina, we have 31555 at the end. Uh, So as you can see, 5377 is the last field from Mina to USD. The same thing is available on chain for this data. So this is the latest data that was generated for Mina asset. So I'll go over to the. So this is the main package that anyone can interact with. So this is shipped as this package, Doot Oracle / client. So it installs this client package. So it essentially calls the API endpoint that is running for Doot, gets the price, converts it to and returns the client object that the person can use in the interaction scripts. So as you can see, mhm, in this case, like we can directly convert it to OpenJS compatible format since the data is already OpenJS compatible. And we can use this in our interaction scripts and send it on chain. So we can set the exchange rates. This is like just a simple example where we can use Groot. So additional points that I would like to say, we made Doot with lots of love and wish to see it empower the upcoming ZK5 applications on Mina protocol that prioritize verifiability just as much as other aspects of the project, because usually these things like if we go over to Ethereum, these things might be like people usually overlook. And so this is something like Mina protocol is usually like push forwards verifiability. So this is like one of the reasons we have it. And everything we do is open source, transparent, and verifiable. So in that sense, we always try to be true to our values, and we'll always continue to follow the same thing. So for the future, like what can we expect from Doot? So while Doot is already in production, we are constantly looking for more ways to improve it, decentralize it further, and support anything related to Mina protocol. So right now, like since we had the recent update, the current Doot protocol works with OpenJS 0.18 version, I believe. And this month, I'm trying to update it to OpenJS first version, and that also includes updating the interaction scripts that are compatible with DevNet. So along with that, we also had with the latest OpenJS update, we had ZK program async circuits. So we are planning to utilize this for the price generation module of Doot. And this will provide the developers with a trustless way to further verify the process. This is also being worked at the moment this month. For the next coming one month, I believe we'll be optimizing the UI for fast loads and calls to the data providers. So because of certain rate limits, and we usually face the like dilemma of adding more assets or reducing the time it takes to update the asset. So by what do you say, improving the cost of the data providers, we will be like, we are projected to add another 10 assets to be tracked by the end of June. About like, after all of this is done and said, like, what we want to do is to bring data from EVM native oracles like Chainlink and API 3, to name a few, that are not available on Mina in a verifiable ONJS compatible format. So this is still like, I'm under the process of figuring out how we can do this. So this is experimental feature that will be coming out later at this year. And at the end, the final end goal for any Oracle project should be having an Oracle network. So in that sense, we wish to create a Docker container that will be able to employ all the features that we have already implemented to get the price for a certain asset, and like make it available for the users to, what do you say, to deploy and run as an Oracle network node. So this will further, what do you say, increase the decentralization, which we lack right now. But later this year, we hope to create the most simple model of an Oracle network that people can deploy and work with. So further, what do you say, establishing Doot as a decentralized Oracle for price feed specifically on Mina protocol. So these are the links that people can visit. Q&As.
Thanks, Anuj. I don't have any questions in the chat, but maybe I can put you on, and maybe it would be, well, I guess this is more of a general Oracle question.
Oh,
So it
yeah,
might be.
sure. I actually missed one point.
Oh,
I
please
forgot to
go on.
mention it.
Yeah.
Yeah. So we like, for navigators, we had multiple improvements over the span of 3 months. So one of them was like, the original UI was like way too simple. So one of the things we did over the past 3 months was improve the UI. The other things was implementing the slots functionality. So what it does is, it allows any, what do you say, any user to participate in the community census. So like, upon clicking the join consensus button, you can become an active participant in the consensus process. So what it does is, so if you believe that the data that is generated here is true, and you wish to like endorse it, you can click on this button. So it what will do is, the data and this, what do you say, the public key, the data, and the signature that is displayed to you will be signed by your private keys. And what it does is, so after this is done, it says signed and confirmed successfully. So the main point where this specific feature is used is for the historical prices and the price that is pushed on chain. So historical prices, the model that we are using right now, what it does is, every 30 minutes it pushes the price as historical information. So that is why, like, if you go over to, for Mina specifically, like, let's say we have a historical information for the past 24 hours. It goes back to like 24 hours exactly, and there are 48 entries or 49 entries usually. So if you believe like the price generated that you see in front of you is fine, you can join the consensus. And what it does is, it prioritizes this specific price generated over all the price generated for the past 30 minutes, and these are given priority. So what it does is, it what do you say, Mm, it supports the fact that the price that you see in front of you is what do you say, is trusted by the community. And the same thing happens for the price that is pushed on chain, the Merkle root and the IPFS hash. So if a specific slot over the past 2 hours gets the maximum number of signatures done, it is given priority over every other slot that is available for the past 2 hours. So this is like one of the things we came up with, that can enhance the decentralization initiative for now, until we don't have an Oracle network. So this was one of the things that people can go over and help with the decentralization. Yeah.
Awesome.
I hope that was yeah.
No, it's very good. Thank you for adding that. My question it could also be a little unfair because it's more Oracle related and not necessarily Duth one. But
Okay.
then, there are like times when the price is like very highly volatile, where each of your source could report something which is not matching or not falling into some kind of standard deviation. So in this case, how does Duth handle such cases?
I think at any point, if we are using at least 14 data providers, at least 6 of them will come to a conclusion, like a figure that is more closely packed.
Mm-hmm.
So in that sense, using the median score, we can remove the other one. Like the number of data providers that will be considered would be low, but it will still generate a relatively common price that is available for the market.
Gotcha. Um, I don't have any more questions. I believe you answered like the past, present, and the future. So
Yeah,
thank
I
you,
hope so. Yeah.
thank you very much, Anuj, for coming on and sharing your work with us.
Thank you so much.
Have a wonderful day. So that being said, we are at our second last project. So Rafa and Tito, if you're online, please share. Yep. Hey,
We are here, Harish. Nice to
nice to see you.
meet you. Yeah.
Hello. How you doing, Harish?
Hey, great guys. How are you?
Okay, perfect. So I'm gonna share my screen. Let me know if you guys can see it.
Yep, looks good.
Okay, perfect. So, okay, good morning or good evening. I don't know where you are in the world. My name is Rafael Campos, and with me is Tito Thompson. We are going to present our projects, the projects that we developed under the Mina Navigators program. We are going to focus on just 2 of them. We developed like 3 or 4, but we are going to focus on these 2, which are the ones that provide the most impact to the community. The first one is called ZK Arcade, and it's basically zero knowledge games, an arcade for zero knowledge games in XR, very important, and ZK Notary, which is a ZK Oracle for Mina powered by TLS Notary. So this is the team. This is Tito and me. We have been working as a team for navigators, even though the program is intended for individuals. So that's why we are presenting together today. So this is the agenda. I'm gonna talk first Tito's gonna talk very quickly about ZK Arcade. And then I'm gonna take over and explain ZK Notary. And finally, we are going to present also a demo. So Tito, if you want to proceed, go ahead.
Okay, sweet. So this I don't know, I'm sorry ahead of time, but we're going to be switching screen sharing. Just it's easier that way because I'll be demonstrating part of ZK Arcade and ZK Notary. So yeah, sorry ahead of time for that. There, now. Okay, should be up. Okay, do you guys see it? We're all good? All right, perfect. All right, so this is ZK Arcade. And to get a high-level overview of it, and Ralph already kind of prefaced it, but we're going to spend around like 5 to 7 minutes on ZK Arcade because this was like the first half of ZK Notary for us, and we spent a lot of time on it. And then we pivoted to ZK Notary, which I'll get into why afterwards. But nonetheless, this was still a really fun project and really pushing edge on what was possible in O1JS, I believe. So the original vision for ZK Arcade, it was essentially, as you see, it's a collection of mixed reality multiplayer games built on Mina to help make tuning a thing of the past, right? And it was the idea that we wanted to, which is common for all types of games, many games like Fog of War-like games, where you want to basically ensure the authenticity of the other person's actions, the other person's moves, and there's no cheating involved. And the 2 games that we had in our roadmap were both Hot and Cold was what we implemented, and ZK Battleships, which is, I think ZK Battleships needs no preface. I think everyone knows what that is. But for our case, all we really from start to finish was hot and cold, and that is this. And what you're seeing now on my screen is just like the landing page for the site, and how we had it configured was you could sign in, and we use Clerk, and so I'll just like sign in with GitHub, and then from here you would get brought to the landing page, and then so here you were able to add friends, remove friends, find them, and the benefit of this was because all the games were multiplayer, especially ideally all the games would be multiplayer. Hot and Cold is multiplayer. It's a 1v1 strategy game, and I'll get into exactly what that is in a second with demos. But throughout the site, we have features like, again, add and remove friends list. You can invite them to games. So if I want to invite, say, Rafa, right, just simply invite him here. I'll actually do that real quick just to show here. So invite him, he would get it when he was online, and he could join. And you can also invite from here as well. And at this point is before I continue on with hot and cold, I'll just showcase the rest. So here as well, you have like notifications to see if you received invitations or friend invites, but as well as a sandbox section. And the sandbox was kind of meant to have a way of to showcase the mixed reality capabilities we're implementing in hot and cold, right? Because a lot of the things we had to do behind the scenes in hot and cold had a very specific goal attached to it. And so like a quick demo of that is something like this. And don't mind the floor, me being on the floor, but this is part we were working on, which was new NextR. This was another library that used Rapier physics. And it was just tying in the MetaQuest 3 to allow for like really good hand physics and using like a skeleton like shape. And so everything would react with the physical world naturally. And then there's this one, and then yeah, this as well. And so this is stuff that you could do in the sandbox mode to try it out. But that being said, now to hot and cold. Hot and cold, the whole purpose of the game was to you and your opponent would first start in your own rooms, and then once both of you are ready, you would then be sent to your opponent's room. And here's the video showcasing that. Right, so we're getting ready. You can highlight it, and we skip through. So now, right, I'm in my room, and then all of a sudden now I'm in Rafa's room. So this was his layout. And the whole point was, I don't know why I keep pausing, but then I have to hide the ball somewhere in his room, wherever. And he does the same for me. You see, like, that's my monitor, that's my light, those are my desks. And then from here, right when both players are ready, then you have to find it. And we just created a flashlight effect and by just simply shader manipulation, and then we're able to find it. And so how we had it for demonstration purposes was you had one version that was just normal, but then with the Mina integration. And so with the Mina integration, it was as simple as by default, it would just be toggled here. And how we were able to power this was through a ZK program. And so this was it, essentially the ZK program, as well as a lot of things that we did with Object 3D and Room. So the validate room was the ZK program. It took the public input in room of object commitment. So yeah, the opponent's room layout and the commitment to the object's position of like where they put the ball. And then the private input when you called the method was Object 3D. So that's like the exact input. And then from here, it's essentially just validating that the ball was inside of the room, and then that it wasn't inside of an object as well. And so if I go to what should be here, this is Rafa did a great job with ZK3D, and what this enabled was us to essentially have 3D geometry within O1JS so it could be provable. And so we had to configure it, base it off the struct. So we had to extend it off struct. And here we just made special use cases for each one. Like, so we had the plane, right? Because at the end of the day, all your walls are just planes. And even some of the parts of the boxes from Meta, like they release that data. We get So we had the plane and also a box, and then the sphere. And yeah, so again, I would go into a lot more detail, but I want to save enough time for ZK Notary. But this is how we were able to authenticate where the ball was to make sure it was in the right spot. And yeah, so this was really fun. It was really interesting, kind of pushing the edge on here. But that being said, so now I would say the reason why we pivoted from here, even though we had a lot of fun doing this, we really believed that we were kind of pushing the edge in Mina and like really seeing what was possible with O1JS. Was there were a few main reasons. One was that it caused very bad screen tears while the ZK program was running. And we actually tried to do it with a contract as well, and that didn't help either. And we believe it was just due to the hardware capabilities of the Quest and how the web workers worked in nature that right when the ZK program would start running, you would just, if any of you have ever used a VR headset, you're aware of like screen tearing, like, so that could sometimes happen and get you really nauseous. So from a user experience standpoint, that's just like not good. It's just not ideal. We can't have that. And then also a lot of people in the community, which is unfortunate, but it's a sad reality that was obvious and we had to accept, was that just many people in the community did not have the extra mixed reality headsets to use and to try it out. And so we really couldn't like have people in the community try it out and use it. And that was upsetting. But then this is then the main decision, the pivot was we realized that we need to do something that is more impactful to the broader Mina community, something that will actually, that ZK app developers could use in their applications on themselves and really do the most impact with this. So even though we had a great experience doing this, we pivoted to then ZK Notary. And that is where Rafa will get into now. Oh,
Yeah, Rafa,
is it
you're
me
on
or
mute.
Rafa's muted?
No, Rafa, you're on
Yeah,
mute.
sorry. Can you hear me now?
Yep.
Yeah.
Okay, perfect. So yeah, that was ZK Arcade. Now I'm gonna go into first explaining what TLS Notary is before I explain what ZK Notary is. So TLS Notary is an open source project sponsored by the Ethereum Foundation. And basically what TLS Notary tries to achieve is solve this problem that we are going to see right now. So here's Alice trying retrieving some data from a web server. Think, I don't know, Facebook, Twitter, GitHub, whatever. So she is certain that the data hasn't been tampered with because TLS gives her that assurance. Okay. The problem is what happens if Alice needs to send that same data to a third party, in this case, Bob. And the problem is that Bob cannot be certain that the data wasn't tampered with, that Alice is not doing something with the data, because that's just not how TLS works. TLS works just between the web server and the web client. Beyond that, there's no way, at least without TLS Notary, to guarantee that the data wasn't tampered with. So we say that the data is not portable. So TLS Notary, what it does is it provides this portability to the data. So with TLS Notary, Alice can send the data to Bob, and Bob can be sure that Alice didn't tamper the data. I mean, didn't modify the data. And the way this works is using multi-party computation. So what TLS Notary does, it splits the keys, the TLS session keys I'm talking about, the signing keys and the encryption keys. It splits the keys between Alice and the notary, which is a new component that needs to be used here. And then the notary and Alice together, using multi-party computation, are the ones who negotiate the TLS session with the web server. And then the data is sent to Bob. And Bob can be sure that the data wasn't modified by Alice, because Alice cannot modify the data because she doesn't have the whole encryption and signing keys. Okay, so this is basically the theory behind TLS Notary. So TLS Notary is a Rust code, a Rust project written in Rust. So the original vision behind ZK Notary, which is our project, was to create a developer-friendly layer on top of TLS Notary. For example, allow a ZK app developer, to use TLS Notary without having to mess with Rust or any of those intricacies. That was the original vision, and that's exactly what we delivered for the ZK Ignite second cohort last year. So this was the original architecture. The way we abstract the complexity away from the developer is by wrapping the prover part of the TLS Notary service inside a REST API. So Alice doesn't need to run any Rust code to generate a notarization for a given website. She only needs to invoke or call a REST API, which is the layer that we added on top of TLS Notary. So for example, here, Alice is trying to notarize a tweet. Okay, so she asks, contacts the prover with the notarized Twitter endpoint, and then the TLS Notary engine is the one that retrieves the tweet from Twitter and notarizes it and send that notarization back to Alice. And then Alice can share this notarization with Bob, and Bob can verify that the notarization is original, is valid, using, again, in this case, npm package in JavaScript that we created from the Rust code. We compiled the Rust code into WASM and then published an npm package that Bob can use using JavaScript. So that's how we managed to abstract away the complexity from the app developer. That was ZK Notary pre-Navigators. So now, for Navigators, we decided to extend the functionality of ZK Notary to include the possibility of verifying that the notarization is valid from within an O1.js contract. O1.js code that wasn't delivered during the ZK Ignite cohort. So we decided to change, to pivot into this other project. And in order to be able to provide this functionality, we need to solve two different challenges. The first one is how to verify the signature that the TLS Notary uses to sign notarizations. That was the first challenge. And the second one was how to verify the commitments to the redacted parts of the notarization. I will talk about the redacted parts later on. So first, for the first challenge, signature verification. We had the problem that TLS Notary uses the ECDSA signature on the SCCP P256 R1 curve, okay, also known as P256. O1.js doesn't have support for these type of signatures. It has support for the K1 version, the one that is used by Bitcoin, but not for this one. So we had either to implement P256 signature in O1.js or extend the TLS Notary code base to support Schnorr signatures. And we decided to go with the second option, mainly because there is already Rust code for that within the Mina Signer crate. Okay. So basically, during March, that was the whole focus for us. We basically took the Rust code from a Mina Signer and incorporated that into TLS Notary code base. Obviously, in a fork and a different branch that we hope eventually will be included in the main TLS Notary code base. So we touched three different TLS Notary crates: the Notary Server crate, the TLSN core crate, and the TLSN verifier crate. We added code to all of those. So on the Mina side, on the O1.js side, once we managed to create Schnorr signatures on the TLS Notary side, verifying those signatures in O1.js was very easy, very trivial, right? This is basically the code that we use to verify the signature. It's very, very straightforward. And that's because the difficult part was modifying TLS Notary, not doing anything on the O1.js side. And just to make, to show, give you an idea of what we did on the TLS notary side, on the Rust side, we basically added Mina to each part where the P256 signatures were used. For example, we defined a data structure called data that could hold the original vector of integers for the P256 signature, but this time with base fields, which are basically the Rust version of field. And then, for example, we also created, originally the TLS signature struct was just P256. We added this one, Mina Schnorr, that wraps around the Mina Schnorr, the Mina signer signature type. And also with a signing key, we added a Mina Schnorr signing key. And this on the right is the code that actually signs data using Mina Schnorr on the TLS Notary project. So we created a context. We used the Kimchi version with the testnet as the domain parameter, and yeah, then we created the actual signature and returned the Mina Schnorr signature. So yeah, that's basically it. One more thing, I said that we had to solve two challenges. That was the first one, the signature. The second challenge has to do with the redaction feature of TLS Notary. So TLS Notary allows you to redact some parts of the notarization. For example, the authentication tokens or anything are actually that you want not to disclose to the notary. The way that TLS Notary does this is using the Chacha algorithm to generate commitments to the redacted parts. The problem is that there's no implementation of Chacha in JavaScript right now. So for us, it will be very challenging to try to create the support for Chacha. And it's not even necessary because already the TLS Notary team is working on a rework or a rewrite of the TLSN core trait to support other algorithms such as Poseidon. So they are already working towards that. So once they support the Poseidon, it will be very straightforward for us to verify those reductions in No1.js because Poseidon happens to be Mina's native hashing algorithm. So this is still hasn't been done. Challenge number 2 is still pending. Okay, so now I will pass it to Tito to show you a demo of our web app.
Okay, so here. Okay, so you guys see this? Everything's good? Just pour carry on. Okay, perfect. All right, so here is just a minimal front end that we spun up to have people easily try this out and demonstrate it. You could find it also on ZK Notary's GitHub link. And here it's actually like very, very simple. And we really wanted to make sure that it was really, really easy for anybody to test out. And so the documentation's really well done. Shout out to Rafa. Rafa did a really good job with a lot of the documentation, especially also how to get this running up locally. It's as simple as like 3 commands. And I'm not going to do it again because if anybody's worked with Cargo, if anyone's worked with Rust, they understand how long compilation time take, like build times take. And so I'm not going to build it from scratch, but it could take literally like a few minutes to do it. So if you want to do it it's as simple as running, you clone it, git clone, ZK Notary, at the root, and pmp install, build Mina, then dev. That spins it up. And what we have right now is we've had this running since the end of April, is an AWS server that's currently hosting both the TLS Notary, the actual like prover on our side, and then also the Notary server, and they're communicating with one another. So that's actually what this web app is connecting to right now. I'm not running anything on for the Notary server or the provers. That's done already. And so here I've already connected my Aura wallet, And we just made two simple examples. And we want to, I'll highlight this later, but I want to be clear, like there's a lot of different ways this can be used. These are just two very simple examples, but later on I'll go into details about how this could be applied. And so, for example, let's say just click GitHub. And then the point of this example is to be able to notarize the commitment history for a specific user for any given public repository. And all you need is, so the go-to example I've just been running is if I do 0x Tito, so that's just my GitHub, and then Space Race is again an example I've been running, a little game I made. And I'm just going to do from March 13th to then the 15th. And so now when I click notarize, so it's notarized at GitHub. It's actually hitting the prover, which I could show the code for in a second after this. And again, we really wanted to emphasize how simple it could be, because a lot of the work again is done in the back end. A lot of things that we hope ZK app developers don't worry about. Like we don't want them to worry about this stuff. It's the point is, as Rafa mentioned earlier, it's about just hitting a REST API, and it's as simple as then retrieving that information. We really want to make sure the process is streamlined in that way. And so now GitHub data notarized, and so we can see the proof. This is the entire proof that's generated in here, and yeah, could go through our bit by bit, but here is the transcript for it. And so this is the actual, the transcript we have back. And as you see here, as Rafa is highlighting the redacted part. So I've been using like on here that anybody spins up, anybody tries, it's my GitHub API key, my access key. And again, I don't care, everybody can use it because it's redacted. So you can fetch any data, and it doesn't matter. I'm not leaking my information. Do as you will. And then so here, you could actually see, as all we did was literally just hit the GitHub API, but we did it through the prover. So particularly we went hit the prover, and I guess this would be a good part just to demo it. If here, yeah, so this is what you would hit. Just the server action, we pass in the username, repo, since and until, the data I filled out. And then this is the IP address for the AWS server, and at this port. And so here we hit it, it just pats in specific args. And then from here, we have, I'll just go to the, I just had this one, hold on. GitHub prover here. So this is the code for the prover itself. And then one more thing I'll just pull up is main.rs. Yeah, so this is it. We have this route. Again, so you can hit any one of these. Two that we have like properly configured for the examples are GitHub and Etherscan. So if I go back here, what happens is, and for time's sake, won't go through all the parts of the code, but I'll go through the parts that are important, that are essential to at least highlight, is setting up the notary connection. And then from here, right, we're connecting, we're spawning Tokyo. And then from here, this is the actual request that's built. And we take this information, and from here, we send the request, it's request, it sends, and then once we get it back, we actually start the notarization process, right? So we send the transcripts. We also specify then what exactly we want to leave out, right? So here we have it detailed on what exactly we're leaving out. And so the redacted part is commit to. So we're skipping over that. We're building it, and then we're building the session, and then the session proof and the substrings proof, as you see over here, right? That's session, and then scroll down enough, find it. It's too far, too hard to find, but you'll see all of that. And then from here, just using JSON, we stringify it and then send it back to user. And then that's exactly what they get here in this proof. And then in the transcript, it uses that WASM crate we were talking about before that Rafa highlighted. So it essentially just parses it, it verifies it and parses out. It doesn't do any manipulation on that end. And from here, if you go to verify, so just verify locally first. Takes a second, also spin up the console. Yeah, right. Again, this is everything, but let me do it again. Yeah, proof is valid. So it runs it, but then also Now I'm going to compile the contract. Of course, you could do this right when they load in the page, but just for simplicity's sake, for people trying this out, we'll just make it only once they actually have something to prove. So as the contract's being compiled, which Rafa showed before what the contract was, that's exactly it. It's the same thing we're running here. And then yeah, see, so WebWorks spring up, compiling. And then perfect. So now we can verify on-chain. And so now we're actually sending the transaction. And well, the transaction is being built right now. And at this point, once the transaction is properly built, here, of course. Let me just get my own password. Yeah. There. And so, yeah, as you guys have all know, this is how it looks like. We send transactions, so confirm. Bam, transaction sent. So now I do hit, go here. Now the transaction has been sent on DevTrain. And at this point, you know, though, like even if the contract was, if the transaction was able to be built, then you know it's fine, because it proves it beforehand. And then so now it's just being asserted on chain and being validified, certified on there. So yeah, that's part of the demo. And from here is, so go to, yeah, this part, and let me just slideshow it. Okay. So this is the potential applications that we see, right? In general, just proof of authenticity of any data that could be retrieved from an API through HTTPS. It really can be any data, as long as there's just a RESTful API that you can hit. And the important part is, which actually I'll elaborate that in a second, is another example is just proof of asset ownership from other chains. A user could call a method on a smart contract only if they own at least X amount of a given ERC20 token, right? So like on Etherscan. So if you wanted to check information from other chains, you could do this. Proof of bank account balance through the bank's website. Proof of real world purchase through the merchant's website, like i.e. like something like Amazon. And here is, again, just a diagram, like any web servers. And this is then, it's basically on the right path of like a true ZK Oracle, like a truly decentralized trusted ZK Oracle. This in and of itself is not a ZK Oracle, because the problem is there's still a trust aspect to it, of course, right? But here it's solving that one step. By now, at least the ZK notary and the notary server talk to one another. And then once that information is retrieved, it sends from ZK notary to the verifier. So yeah, we really believe, and we know, we're confident to say that this is like a good step in the right direction of a truly decentralized ZK Oracle, which is ultimately the aim in a lot of use cases. So we're really excited about this. And yeah, the route ahead. And so, as mentioned before, TLS Notary currently uses the Cha-Cha algorithm to generate the commitments to the redacted data. However, the team at TLS Notary is actively working to add support for Poseidon hashes, as Rafa mentioned earlier. This is being done inside a separate branch called Notarization Redesign. Once this branch is merged into main in a few months, it should be possible to verify redactions using O1JS, which could in turn make it possible to offer the full functionality the Rust-based verifier provides now. So again, just to iterate, once that they really do the refactoring and they allow for Poseidon hashes, you could authenticate and prove the entire proof that's sent, not just the session header, but the substrings, the actual content of it, and as well as the session headers, all of the above. And yeah, that's it. That's our presentation. Thank you for listening.
Well, thank you guys. That was really enlightening, and thank you for all the work. I don't see any questions in that. Yeah, Anuja is asking, We can run our own ZK Notary at AWS, or is it a centralized notary at the moment?
Yeah, you can certainly run your own ZK Notary on AWS. In fact, in the ZK Notary repo, you can see instructions on how to do that. There's a subdirectory called AWS where you have some scripts that will allow you to deploy easily a notary server on AWS. So yeah, you can run it yourself. Right now, we're running our own, but you can run your own notary server. Yep.
Yeah, if you're still watching my screen, it's all here too. Again, the docs are really thorough about this, especially the provers. If you want to run the provers on your end, run everything from scratch.
P256 verification support in One.js. Well, I don't think so. It's not necessary because, I mean, a Mina Schnorr signature and a P256 signature are equivalent in the sense that they certify the same thing. So if we already have support for Schnorr, I don't see why we would need P256 support as well. The recipe server has access to the redacted data. No, it doesn't have any access to the redacted data. Only Alice, the prover, has access to the redacted data. So neither the notary server nor the verifier, or Bob in this case, have access to the redacted data.
Cool, awesome. I don't think there are any more questions. So thank you both, Rafa and Peter, to come on and present your work.
Thanks, Harish.
Have a lovely evening.
Thank you.
Thanks.
Thank you all.
Bye.
Right, guys. So on to the last one. We have Mina NFT. Mikhail, if you're online.
Yes, welcome to Mina NFT. Let me share my screen. Okay, so welcome to Mina NFT. Mina NFT allows you to mint new generation of the NFT on the Mina network and now on Zeka. There is now support for Zeka, so those are first NFTs minted on Zeka network using new rollup NFT technology developed. We just finished it doing it. So you can basically have picture, you can have video, you can have PDF file, or whatever you want to add to the NFT. There is quite rich format that allows you to add anything that you want. And also some keys. So you can have some public keys that are reflected on the web and you can see them. Or you can see and add some private keys that only the owner of NFT can see. Can be so for example, in this NFT, there are two keys. One that we've seen, it's hard fork. It's public and we can see. And the second, called when, it's private. So it does not in the public information at all. You can create quite easily your own NFT. So you need to choose chain. The classic contract is now deployed to DevNet. And the new rollup contract is deployed to the Zeka network. You need to add image. You need to name it. Let's name it Navigator. Then you can add description. You can add additional files like video, and you can add also some additional data. Let's add one public key. So let's say that session 2, and let's add some private key. Let's call it when, and let's say it's June. Okay, so we're done with content. Let's now mint. Let's pay 10 Mina fee. for meetings, and let's wait while it's being sent to AWS for preparing transactions and sending to network. Okay, so transaction was sent. Now it's being processed, and we can open this NFT. Let's see. Okay, it's loading. Right now, yes, that's our NFT. We can see now session 2 because it's public key, but we cannot see the private key now. So in case we have now 5 NFTs on Zeco, and the last one is Navigator. So let's speak about what Mina NFT is. What parts do they have? In Mina NFT, there is front end. We just seen it. There is some backend API that is working on Lambda and do all compilation, recursive proof, and all that stuff. Then there is library that allows you to integrate very easily all NFT features to other projects. There are some AI tools that allow you to generate quite interesting content with help of DALL-E, Whisper, and ChatGPT. You can speak with AI on your language. Actually, according to my statistics, and I already have thousands of requests to Mina NFT during last several months, like 80–90% of people prefer to speak in Turkish with Mina NFT bot. Let me show how this conversation look like. Let me add, just a moment to make sure that. So I asked the bot, please generate a nice picture for NFT. And the picture was generated. I can edit something to it. I can ask to change it. And in case the user is something inappropriate, ChatGPT is filtering such request, and then the bot answers that, sorry, I cannot make such a picture because it's violate terms of service. So I received the pictures, and I asked the bot to do NFT, and I asked to put 2 keys, what hard fork and when June. And I asked to make when key the private. So the bot started to do it. It did all compilation, all proving, sending to network, and sent the transaction to the network. So we can basically see this transaction details on Mina scan with all account updates and all that stuff. And we can also see it's on Mina NFT site. So it's Mina, and we see a public key here. Then, of course, I received some invoice for $10 for meeting, and asked to leave the keys of this NFT. Because I'm owner of this NFT, I have access to private information, and I receive full information about the key. So then I asked to prove the key when. A recursive proof was generated, and I received it as some file that I can later verify. So let's open this file. So I have name of the NFT here, I have address, I have the key that I verified, and the proof that I can later verify both off chain and on chain. So I asked the bot to verify the proof. He took this proof and verified using both the state on chain on Mina DevNet and the information in the public input of the proof. So it's example of how you can basically work with Telegram bot. Let's return to the structure of Mina NFT. So there is some documentation site, and we now on this site. There are some examples. There are additional repos for roll-up NFT and so on. And you want to understand basically what kind of API you have. You can just search here, and you will have all the information about all the methods. What you need to prepare some commit information to get the proofs and so on. So everything is here. Let's now speak about what was done in the last several months and what updates I have on Mina NFT project. So two major updates that was just finished in April. The first is roll-up NFTs. Roll-up NFTs do not need to have state kept on L1. They can use their state kept on rollup, and we will see later how it's working. And therefore, it allows for easy integration with any ZK app, with any rollup, because it's up to rollup or up to ZK app to decide how should be stored the state. And the state for each NFT is 4 fields. 2 fields are keeping IPFS storage that is used as off-chain storage, and 2 fields are keeping metadata root. And all the information about this NFT is basically stored in some forest of Merkle trees. And we can see here, for example, so we have metadata. Those are metadata roots. There are 2 Merkle maps. And then for each property in this map, there is some data, some kind. Is it string or is it image? And then it can be nested. So for example, image use several trees to keep all the content. Now we have video, and video also have own trees to keep all this information. And everything can be verified. So every byte of every file can be verified. I have example on it. If we go to documentation, I will not right now go into much detail. There are a lot of interesting stuff. So you can basically redact proof. It's very similar to the previous presentation. So basically you can apply the mask to the file. For example, you want to prove that it's Red Hat. And then you can create a proof that can be verified later to make sure that basically this redacted information is absolutely the same that was originally written as some image, and it can be fully proved using the metadata that is being stored in rollup or on chain. The next addition is command line interface 2 that allows us to prove, verify, and see all the information on that stuff. So this tool is called Mina NFT. I'm not sure that you've seen it very well. If it's letters too small, please let me know. So basically, you can ask many interesting things about rollup. Let's ask about list of NFT names that exist. So we see all the names, and we just created Navigator NFT, and it's also listed here. We can ask also about what kind of blocks have the rollup, and there is full contract state. There is information about every block and information about what blocks are proved, what are added, because the block first being created, and now last created block is block number 5 that contains information about the Navigator NFT that we just created. it's already validated, but it's not yet proved. If we go into some details of how it's being done, that basically there is some roll-up contract on Zeco, and this contract, it's a token contract. So basically, each block is a token account that's being created on Zeco. So if we go to Explorer and would see, let's update because probably, yes, we already have new information. So it's the block, yes, it's the block that we just created with Navigator NFT. So the block was created, but was not proved at the beginning. It was just created as token account. The next, some validators load off-chain state from IPFS, recalculate this block to make sure that it's calculated correctly, and confirm that basically what is contains on off-chain state in IPFS is exactly what is written on the block. They sign it, generate proof, recursive proofs with signature for validators, and they send transactions that is valid. And the last transaction confirming the block, recursive proofs that prove that basically state mutation of the contract is absolutely correct, and all transactions are correctly included into the state, is being calculated. And here everyone can calculate those recursive proofs, not only validators, because validators already confirmed that off-chain state is valid. So anyone can calculate this recursive proof, can send it to the contract. It will be checked by the contract code to make sure that proof is valid and confirm that state in the contract is valid. So basically, all last three transactions, it's what we just created when we created NFT Navigator. And each block can contain easily 100 to 1,000 transactions. So we don't have any limitations on L1 in this case, because we can put huge TPS with such architecture. As we can send mail to sequencer many transactions. They will be included into one block. And then the block will be confirmed by validated and proved by anyone. And as I said, basically it's how it's being block state is being changed. First it's being produced, then validated, and then it's being proved. It's what we see basically in the contract state. This tool also allows you to get any information about name. Let's ask information about upgrade name. It's with videos that we've seen in the beginning. It's getting now information from the state, and now we have full information with from the chain. So we can, for example, copy link to this URI and see what is written. So we have full information about public information, of course. So there is no private information here. We have only public information here, and we have all the other information as well. Okay, let's imagine that now we want to prove also private properties, all properties. So let's prove keys of upgrade, and we are saying to this command line interface tool that we want to prove keys for NFT upgrade, and we want to prove two keys, what and when. Let me put debug mode in, so we will have a lot of service information. So first we're receiving information about the contract address that we use on chain Zeca, and we use last block. Then we receive information about last block. It contains all information like block creation time. And what is important for us, it also contains all transactions. It's last transaction we just created for Navigator, but we don't interested in it. And it contains database of all names and Merkle map, serialized Merkle map that is we will be using to fast produce the witness. Let me show. It's basically just huge file with all the details of Merkle map, and it's use base 64 encoding, because otherwise it will be just too huge if I will use usual encoding. So we have database here, and we're interested specifically in upgrade. We have some fields here, it's also encoded in base 64. This is being decoded now, and we're getting naming for here with this field. And then it's being converted to fields. So we have all this information with address, metadata, storage, all that stuff. So now we can analyze all this metadata and start working on key values. We receive information of all key values, including private, from local file that is kept on my local drive. Otherwise, I will not be able to generate a proof for this NFT. So now we see that we have two keys, vote, that we already seen in public space, and second private, when June. So we're analyzing it, compiling verification contract, creating the proof, and verifying it to make sure that it's absolutely valid. Then we create second proof. Those are proofs that are created. They are huge as usual, and we have now the file that contains all those proofs. So we see that there are two keys, service information about it, and there are two proofs. Rollup proofs, it's proof of inclusion of this NFT into rollup. And the second is the keys proof, is proofs that those two keys are actually part of the NFT metadata. Okay, so what if we want to now prove on chain that our private key is actually valid? So let's generate a proof for it. So now we want proof on chain, on Zeka chain, that NFT upgrade contains value June for key value. That's also in at debug mode, so we would see the process. So it's very similar. We're going also through all these data structures to get all the information and to basically to prepare two proofs that we need. Let's now look at the contract briefly. So we have key verification contract. It's the key program that confirms that all the keys are actually included into the Merkle map of the contract of the NFT, and rollup verifier. This ZK program confirms that basically all the this NFT is included in rollup as part of the Merkle map of the rollup. Okay, meantime, blockchain already initialized. We got deployer. We compiled all the contract, and we sent. The transaction was sent, and also the file was generated with all the proofs. We have the status rejected, but it's not true. Simply Zeka is quite young, and O1JS has some bugs on sending. Actually, I'm quite sure that this transaction is included. Let's look. Let's find this transaction that we just generated. Okay, so Mina NFT verified, it's applied and successful, and it's if we look at the contract that we used for it, so we have like many transactions that do such verification in on on that in our contract. Okay, so let's return to presentation. So we looked at command line interface tool. There are much more actually stuff in it. If you will look at help, like more than dozens commands, but I will not go because I don't have time now to go into details. So let's go to presentation. So the second edition that made in April was Zeka NFTs. We already seen it on front end. We already seen how it's structured, and we see some architecture. I can answer more questions. I understand that it's complicated, but I don't have time now to go into details. What kind of experimental features were developed during the last 3 months? The first, we got contracts version 2 on Mina NFT. Those contracts are being developed for the mainnet launch, and they have new mint update, and they have also such methods like sell with KYC, buy with KYC, and so on and so on. And also marketplace is supported into this new contract, and it's intended to be deployed on mainnet. So it's mainnet preparation work that's been done during the spring. It will be a travel rule support, and I plan to use DOT oracles for this. It will be KYC support not immediately after mainnet hard fork, a little bit later, but it's planned and all the methods already exist. Just I need to work more on having credentials for KYC. The packed state, I use more than 8 fields in contracts version 2. So I cannot use statuses, and there are some utilities that pack those extended state into 8 fields using the fact that basically not all variables need 255 bits. The next is 1 second transactions in UI. It was developed, confirmed, and our wallet is now preparing new version that will allow me to use it. It will include sign transaction method. How it will work? On UI, it will be possible first to create transaction, then without compiling or proving, immediately get the signature of the user with sign transaction. So user asks you something. Immediately he receives some prompt from our wallet, he signs transaction, and it's being sent to backend. No compiling, no proving, nothing. It takes 1 second, all this process. Then on backend, if necessary, the contract is being compiled. The transaction is being proved, signed with other keys if necessary. For example, if token account is being created and sent to the network. And it's all being done in the background. So users do not see it. He just see 1 second delay. It's already, the code is already developed. And it's now in experimental stage. So we can see the code here. I can go into more details during the questions if necessary. Integrations with other projects. Now there is work on integration with 2 projects, with Mina domain name service that will use those NFTs, roll-up NFTs specifically, and with social cap. And given that architecture is quite modular, you just need to import the Mina NFT library, and then immediately you get all the features, and you can use Mina NFT site to basically show the full content of the NFT, just with a simple link. let's, for example, look again at the name upgrade. When we're receiving full information about there is some link to Mina NFT. Yes, I just need to copy it, open. Yes, and I'm immediately opening all the metadata with all the video that basically you need. Mainnet hard fork. So after mainnet hard fork, Mina NFT contracts will be deployed to the mainnet, and I plan to deploy contracts version 2 that were developed in March and April with support for marketplace, travel rule, and also I plan to use DOT oracles integrations. Hopefully the contracts of DOT also will be deployed to mainnet, so I will use it. 1 second transaction in UI. It's almost ready. I'm just waiting for our wallet right now, and they're working on it. So hopefully I will be able to finalize it in May. And light version of user interface, because now there are many features on Mina NFT, like various proofs, corporate stuff, tools. It will be much simpler for okay. We got some new NFT during my presentation. Great. Roadmap. After I will finish working on mainnet version of Mina NFT, I plan to develop new front end with better design. I will switch to a new framework with TypeScript. I plan to add KYC support on marketplace. To work on Lightning payments network, because NFTs basically can have any information in regard of all authorization or whatever. It's just forest of Merkle trees, so you can put everything there, including what you want to do with money and so on. So as soon as Lightning payment network will be developed, I can add some functionality to it. And auction. It's a roadmap for this year. Okay, thank you. So it's basically my time is finished. I already over time, so I was not able to cover everything, but there are some links that you can follow, and there is a lot of information and documentation. You can go to all the repos, and for example, it's repo for rollup. There is repo for library, for API, for website, for command line interface. There are a lot of kind of information there. So you are welcome to ask any questions and so on. Thank you for your attention.
Thank you for the lovely presentation. There isn't anything in the chat yet, but maybe I have one.
Yes. Talha said that he tested many times. Yes, actually, I see 80% of the users from Turkey. If we would look how many NFTs they created during all the time, let's ask billing report for it. So we'll see. Yes, so total build time is 35 hours. 35 hours, Mina NFT was working, and 80% of the time for Turkish users. NFT mint at 90. It was 85 in the morning, so we have today 5 more. And thank you, Talha, for all your work that you do in this Turkish community, because I see it every day. It's like sometimes when I see that I received something like 500 requests on Mina NFT, I know that it's Talha mentioned Mina NFT on some Telegram chat in Turkish language.
Awesome. But I have one question because the model is largely different. Let's say if there's a new NFT standard released, would these NFTs be transferable to a new standard of tokens?
Right now, NFTs are transferred. So basically, right now there are two versions of contracts. The first classic contract that deployed on DevNet allows for transfer of the tokens for buying, for selling. It's being done by changing the owner on state. And it can be done right now. I did not allow this functionality in the code, but actually, if you look in the repo, there is buy, there is sell forms, so everything is present. Just I didn't want to allow you to concerns with travel rule and KYC. Now that I solved, have some solution for travel rule, I will allow it, and given that the second version of the contract is ready, I will do it immediately on the second version of the contract on my net. If the new standard will be developed on Mina, of course I can follow it. Right now there is no standard, so I just propose my own interpretation of how those contracts, because those NFTs should be transferred. Any other idea is possible to do, and even if we speak about roll-up NFTs, they don't have owner because it's the responsibility of roll-up to set the owner. Roll-up NFT is just some state of the NFT. There is no information about owner, and it's up to roll-up to decide who can control, who can change the NFT, and so on. So in this sense, I can support any solution. Whatever developer wants, whatever standard wants, it will be just supported by roll-up NFT right now. For the classic contract and for the version 2 contracts, it's not so. In case it will be new standard, I will need to amend my contracts to follow the standard. I amended last time the contracts to follow token standards that was developed by Gregor approximately 2 months ago. It was in March, I guess, when the new 1JS was released with token contracts. And I immediately changed my contract to follow the standard, and now it's kind of the token contract. We can see it in the, if we go to the main contract, we will see, yes, it's Mina NFT name service contract, it extends token contract right now.
Awesome, thank you. I don't think there are any more questions in the chat, and you're welcome to
Okay, yes, if you have any questions, there is on Discord Mina NFT server. I'm always on Discord of Mina protocol, so please feel free to ask me any questions that you have.
Yeah, and you can send the AWS bill to Talha. I'm sure he wouldn't mind. So thank you all for joining the day one's presentation. We will be back tomorrow, and thank you for presenting DFST. I'll see you all guys later.
Thank you.
Take care.
You.
Bye.